Okay, so let's do another example with a shifted vertex. This time we have the vertex at 3, 0. So here's my vertex. Then my focus is at 3, negative 2. So here's my focus. And I can see that this parabola is opening downwards. You can just say down. It opens down, and I can see that because of the relative positions of the focus and the vertex. The focus has to be inside the curved part of the parabola. So this opens up and down is a y and an x squared. So I'm going to have an x squared and a y. My x needs to have a minus 3 now to shift the vertex to the right 3 equals, then we're going to have a multiplier here, and then we're going to have y minus 0. So I don't need to put minus 0. So then we can look at the sketch we've made here and see that A is 2, the distance between the vertex and the focus. So if A is 2, 4A is 8, and that's what goes here as the multiplier on the side that's not squared. So the focal diameter is 8. So at the focus, I need to go 1, 2, 3, 4 to the right, and 1, 2, 3, 4 to the left to get my latest rectum points. So let's go ahead and say where those are. So 1, 2, 3, 4, 5, 6, 7, comma, negative 2, and negative 1, negative 2. So here's my equation and my latest rectum points, and then let's go ahead and draw our graph. And there we go. Okay, so rather than keep making long instruction sets, we're going to have a shorthand that says analyze the equation. And when we're talking about an ellipse, it means, a parabola, it means find the vertex, focus, and directrix of the parabola and draw its graph. So it shortens the instruction set now. Analyze the equation. So here I have x squared plus 6x. And I know I want the squared stuff on one side and the stuff that's not squared on the other side. And I need to do a complete the square here because I know the shape of what I want to have is x plus or minus something quantity squared. So I take my 6 and cut it in half. That's 3. Square that to get 9. So I'm going to add 9 on the left. So I also need to add 9 on the right. So on the left, I can now write this as the perfect square, x plus 3 quantity squared. And on the right, I'm going to have 4y plus 8, but I need to write that as a shift also. So I'm going to have x plus 3 squared equals, factor out the 4, and have 4 times y plus 2. So now I can see where the vertex is, negative 3, comma, negative 2. So let's put that on a graph, negative 3, negative 2. There's my vertex. 4a is 4. So that means a is 1. And let's see, we have y and x squared. So that opens up or down. A is positive, so it opens up. So the focus needs to be above the vertex by a distance of 1. Because the focus has to be inside the curved part of the parabola. So the focus is going to be the point negative 3, negative 1. Then the directrix is at equal distance on the other side of the vertex, but remember that a directrix is a line. So it needs to be the equation of a line. So the directrix is y equals -3. So we've found the vertex, the focus, and the directrix. We know the focal diameter is 4. So stand on the focus and go 2 to the right and 2 to the left. There are your latest rectum points, and draw your graph. Okay, so let's do another example. This time I notice that I have y squared and x. So this is either going to open right or left. Let's see which one it is. So I'm going to have y squared plus 12y, cut the 12 in half and get 6, and add 36. So if I add 36 on one side, I need to add 36 on the other side. So now on the left, I have y plus 6 quantity squared. And then I actually need to factor out the -1 and get -1 times x minus 37. So make sure that makes sense to you, the factoring out the negative. So I can see where my vertex is. Make sure you look by the x to find the x coordinate, and with the y to find the y coordinate. It doesn't matter what order they're in, it matters which letter they're next to. So there's my vertex. So I'm at 37, -6. So here's 37, and here's -6, and here's my vertex. So then I know the distance. Let's see, so 4a is 1. So a is 1/4. And let's notice that we have y squared and a negative. So that means we open left. So the focus needs to be to the left of the vertex by a distance of 1/4. So not very far to where our focus is. So our focus is actually at -36 3/4, if you like. -6, that's going to be the easy way to say where it is. It's because it's at, sorry, not negative. It's at 37 and then back up 1/4. And so that's our vertex and our focus. Then our directrix is that same distance of 1/4 in the other direction. So my directrix is going to be x equals 37 1/4. Well, this is going to be one narrow parabola because at the focus, it only has a width of 1. So that means you go up a half and down a half. And this is a very narrow parabola. Okay, so did we find everything? We got the vertex, focus, directrix, and graph. Good. Okay, here's a little bit different exercise. Find the equation given a graph. So we can see that the vertex is 0, -1, and it opens up. So I'm going to have an x squared and a y. Well, the x has nothing subtracted from it, so it's just going to be x squared. Then the y has minus a -1, so +1. And then we don't know exactly where the focus is. Don't assume you know where it is. But we see that this point 20 is on the parabola. So when x is 2, y is 0, and that's going to make it so we can solve for the a. So don't assume what the a is. Make sure you solve for it. Turns out it is probably where you thought. The a is 1. So the distance from the vertex to the focus is 1. And turns out the focus is at the origin. So our equation is going to be x squared equals 4 times y plus 1. And then as a double check, you could put the point -2, 0 into the equation and make sure that works. Okay, so let's look at example B. And we can see where the vertex is at 1, 0. So it's opening left. So I'm going to have a y squared and an x. But the y has 0 subtracted. So it's just going to be squared. The x has 1 being subtracted. And then I know it's going to be a minus because it opens left. And then I'm going to have my 4a here. I don't know for sure where the focus is, so I'm not going to make any assumptions about that, but I'm going to notice that the point 0, 1 is a point on the graph. So when x is 0, y is 1, and it's a good thing we didn't assume we knew where the focus was, because we're getting 1 equals 4a. So in fact, a equals 1/4. So your focus is a lot closer to the vertex than you might have thought. So we have y squared equals negative x minus 1. And again, you can check and make sure when x is 0, y is 1 and -1, and that works for points on the graph. Okay, then I have one application problem I wanted to look at with you. The inside walls of a bowl have cross sections in the shape of a parabola. The width of the bowl at the opening is 32 centimeters, and I'd really encourage you to draw sketches for these application problems. The depth of the bowl is 15 centimeters. The base of the bowl we're going to have be the origin, so that's going to be the vertex of the parabola, just to make things easier. So it says, what is the equation of the parabola that can be used to model the walls of the bowl? Well, we know that this point, 16, 15, has to be a point on our parabola. So parabolas are symmetric, so if it's 32 all the way across, then it's 16 halfway across. So this is the point 16, 15. It's an opens upward parabola with the vertex at the origin. So it's going to be x squared equals 4ay. So here's our point we know has to be on the graph. So 16 squared equals 4a times 15. So let me divide both sides by 60. And a is going to equal 16 squared, or 256 over 60. And we should reduce that. 128 over 30. 64 over 15. Okay, so that's my A. So my equation looks like x squared equals 256 over 15. I multiplied by this 4 here, y. So that's the equation that can be used to model the sides of the bowl. Okay, so let me know if you have any questions about parabolas.